All right, look what we got it today. Frankford Arsenal Universal Bullet Seating Die. Now, some of y'all might remember I did a video on my Lee bullet seating die. Wasn't real happy with it, but it is what it is. So anyway, we started to buy another RCBS full set for the 303, but I kind of got talked into buying this bullet seating die. So, and it makes sense in a way. Instead of buying a whole nother set of dies, just buy this, and I can also use it on other projects. So anyway, here's what we got. It says Universal Bullet Seating Die, and comes with a bunch of different inserts for it. Now, one of the things was all the guys that, when I told them I was buying this, they said that they wanted a review from me as a good opinion from a machinist at what kind of quality this is. So that's what we're going to try to do today. We got gauges we're going to measure with. I got a spreadsheet and I'm writing all the numbers down, and we're going to just see what it's all about, okay? This isn't about whether it's good, bad, or this is just what it's going to be. This is kind of like an inspection report that I would have to do before I send a part to a customer or something. Just take down the number of what this is, and you put it on a piece of paper and you send it in. That's all it's all about. But I will say some few opinions on it, and we'll start right now with the box itself. Nice box. One of the things that I see, two things on this box that kind of, in a way, isn't a good selling point. First of all, it says works with VLD bullets, so they're not giving you much option other than basically some type of spear point, VLD, very low drag bullets. So obviously the seating stems kind of only work with that, but I think we can make them work. We'll check on that. The other thing is, it doesn't say that this thing makes precision rounds or anything like that. Only thing it's saying is it's got a micro adjustable seating depth. That's all it's saying. So kind of oxymoron, I think. Here is like, you're telling me you're only working with VLD bullets, but you're not saying that this thing's going to make very concentric rounds or anything like that. All you're claiming is a good seating depth. So that's just my opinion on the packaging. All right, let's open it up. All right, got a set of instructions. All the labeled parts. Now, this box, this is not a bad box. It's not a typical blow mold box. It's actually hinged, so it won't be, every time you do this, wear it down until it finally snaps off. So that's a good box. All right, here we go with the parts themselves. 1, 2, 3, 4, 5, 6, 7, 8, and 9 different bullet sizes. Got 1, 2, 3 different stems we can use: a short, medium, and a long. Overall, just looking at it right off the bat, very well made. Machining looks very good. Nice good finishes on everything. Scale's pretty good, readable. Nice good anodizing on the aluminum sleeves. You know, the body is all, the thimble and the body is steel. These stems are stainless steel. Looks like a precision ground stainless steel pins, you know, and machined to what they needed. Okay, so what we're going to do is we're going to disassemble this thing, and then I want to kind of go through what it actually is doing, and then we will go to the measuring parts. So first thing we're going to do is we're going to open this up. This box over here. I'll lay out all the parts here. There's the thimble. You got a stem with a spring. That's what they call the spacer. There's the sleeve itself. So let's take this off of here. So what does this seating die offer? Well, on this sleeve, this has a counterbore in it that captures the case. Now, when you loading, and if you load in from the front window, the bullet goes in there and it stays in there. Now, how does it do that? Well, I don't know if we can pick it up on the camera or not, but there's a little pin in there, and this O-ring groove holds that pin in there. So that pin is being pushed over to one side a little bit. Don't take much to get in there and go through, but it will go through. All right. So once you got the bullet dropped in there and you start raising the ram up, then you got the seating stem that will be touching the top of the bullet. Like that and like that. And then once it's pushed up in there far enough, it'll seat in there. So that's basically how it's working. So what we want to do now is I've picked the ODs and IDs that I feel are important in making a good seating die. Because to make a good bullet or concentric bullet, everything has to be in line. I mean, everything, all the way down to the shell holder, needs to be in a straight line. Otherwise, you got forces pushing this and that way. Now, how close do you really got to get to get it to be straight? You know, that's questionable. Because once you start pressing that bullet into this, it's going to straighten itself up some. But the straighter you can get it started, the better you are. So, what I said, I've got certain things I want to check on it and record those dimensions, and then we'll look at see how much play is in this system. So, well, the first thing we're going to do, we'll start with the thimble. There's not a lot to check on it. You have, inside of here, you have a recess in here where your stem sits in and holds it nice and square. There's very little wiggle in there. The only other thing to check is the threads. It is a 7/8 20 thread. And what we got here is a 2A plug gauge. So no-go goes right in there. Got very little shake to it, so that's good. And this is the no-go. And she will not go. So that's all we can check on that. So next thing, I'm going to check is the die body. All right, same thing. We got a 7/8 20 up here, and we got the 7/8 14, typical press threads on that, or the threads for a press. So let's see. We got a set of ring gauges. We got the no-go and the go. And these are 2A threads. Actually, that's 2B. B signifies ID threads. Yeah. Anyway, this is the go gauge, and very little shake on that too. I mean, these threads are actually pretty darn good. I'm really impressed with these threads. Here's the no-go. Let's see, we got one turn. That's acceptable. That's one turn. So once it gets one turn, it engaging the thread fully and it stops. That's good. All right, 7/8 14, and we got the go gauge here. What we got here? We got sticker coming off. All right, that's got a little play in it, but not too much. Not too much at all. And let's see about the no-go. Same thing. That's it as far as it's going. So all the threads are good. Get all that out of the way now. All right, next thing is, this thing actually has 3 different IDs in it. The bottom one we're not going to worry about. It doesn't really do anything. This main section right here, where this rides in, right through here down to there, you can see how far it comes down. We're going to check that. This is a 630. Let me get my calipers and make sure I'm right for us. Yep, 630. This is a 630 pin. It goes all the way to the bottom. A 631 pin will not go in that far. Won't go all the way to the bottom. I've only brought the gauges that I know I needed to do this. I didn't bring a whole set home. This is a 635. And the 635 actually goes in there that far. So from about right in here, to where that ID starts, there's a 5 thousandths taper. 5 to 6 thousandths taper. So that's not great, because what happens is when this slides in, it's down at the bottom, it's tight, it's pretty straight. But before the bullet ever actually starts to seat, that thing is up in this area already. So it's going to be looser up here. Anyway, that's what what that die body is there. Now the top section, which is where the spacer sits, it is 593. 593 barely goes in there. 594 won't. Or not, what did I say? 653. It is 653. Get my numbers right. So, that's what's on the die body. So now let's go to the seating stem. Seating stem is made out of it looks like a ground and polished stainless steel. And it is 303 on that diameter. So was this is the short one, so was the long and the medium and the long. They're all 303. So that's a good constant number. All right. Now where this goes into it, and I didn't bring those home with me, but I already had the numbers. That ID is 307. So you have a 4/1000ths clearance between these two parts. The OD of it is 646. You got 646, 653. So that's 7/1000ths clearance here. So you got 7/1000ths of play in there. All right, so that's those parts. Now, I think more people were worried about these than anything else. This is the 303 one. The counter bore at the bottom where the case mouth goes into, that is 348. The through hole, 313. A 314 pin will not go in. Now, people were asking about doing powder coated bullets with it. Well, you got these cedar dies that's got a sharp corner on the edge of it, because they're only made for Spitzer type bullets. You can probably round that corner off a little bit and make it work, or you can find somebody that can make you some, or just if you just want to modify it yourself totally to where it works, that's fine. Let me think of here what I'm trying to do again. Okay. Yeah, 313 is the max you can go inside of there. And what we was talking about is as cast bullets, you would have to make sure that this counter bore here where this case mouth goes in will accommodate a flare, you know, if you're wanting to do cast bullets with it. If you're not doing cast bullets with it, and if this is, the looser this is, the less chance of being straight, making a concentric. But you can't have that bore too tight, because you're going to have to be, it's going to be loose some until you press the bullet in, when that'll swell this case out. But so you can't swell it out so big that once you press that bullet in, it's stuck in there then. So those are those things. All right. Next thing was I was going to check concentricity of this part. So we're gonna check the 313 diameter. Well, where'd it go? All right, there it is right there. Kind of hard to hold it still. That's not too bad. One maybe. Well, let's see, where'd it go? Maybe a half thousandths on that. Let's see what the front end looks like here, where the case mouth goes. Hard to hold it still. Less than a half, so that concentricity on that's not bad at all. So we're going to record all that. Now I've already got most of the leg work done as far as all these others. As far as diameters, I haven't done the run out yet. One of the things that I'm kind of disappointed in. Let's see, we'll write these down here when we got it. Oh, we didn't check this. We didn't check this OD. This OD is 628. So let's write that down. 628. The through bore was 313, and the case mouth was 348. 0.348. Yeah, this is a once fired case here, and that's 331. I mean, this 308 bullet will press in there. I can press it in there. So 331 right now, 331, 332. That means that this thing has a 16,000th slop in it here. All right, so when you go through all the inserts, that OD, this OD here, which is letter A, the minimum was 629 or 626, and the maximum was 629. So there was only 3,000ths variance in that OD. Now, when you start looking at the bullet diameters, the 224 was 229 max. So you got a 5 thou clearance on the 224. On the 243 you had 246. You only had 3,000ths clearance, so that's a little tighter. 257 was 259. That's even closer. That's only 2,000ths clearance. 264 was 268, so that's 4 more. That's 4. 277 was 281, so that's 4. 284 was 288, that's 4. 308 is 313, so that's 5. The 325 was 329. That's 4. Now, here's where our problem is. The 338 is only 337. So you're not even going to get a bullet through it. Jacketed hull or cast either. That sleeve's too small. It's undersized. You might press a couple bullets through it and finally get it to work. But right now it's undersized. And then you got all the other case mouth dimensions. They're all pretty good size. And I don't know what they would normally be, because that would be dependent on your case thickness and stuff like that, how much that would work, how much that would be. So that can't determine that. So anyway, let's see, we wrote this down. We said, I'm going to say that had a run out of a 0.5 thousandths on that 308. I'm going to check the rest of these. I'm going to do that off camera. I don't want to bother y'all sitting here doing all that. So anyway, will this thing be that great? Yeah, it's going to be pretty good, I think. Overall, I think what people are wanting to know is this thing worth 60 bucks? In my opinion, yes. The machine quality is not that bad. If you wanted it better than this, better quality than this, of having everything like a 1/1000th clearance on everything, the price of this would go just out of the roof. It would just be too expensive, especially to be a multi-caliber seating die. So the way it is well worth the $60, because you can do so many calibers in it, except the one that I was going to do it in. The main reason I bought it for the 303, it won't work. The 308 is too small, because these are sized to 314. That holds only 313. I could go to the next size up, the 325, and that bore was 329. Well, I'm back to 15 thousandths bigger than the bullet. It should still see them pretty straight and everything, but it's defeating the purpose of having a good setup like this one. So anyway, that's my take on it. It's not that bad of a deal. I don't think it's well worth it. Going to be probably going to see some that's going to have some run out. You know, 2,000, 3,000, 5,000 maybe. Don't know. It's going to be a combination of things, you know. All the different sizes, it can vary on you. You've seen how the 243 was really tight. Or was the 257 was really tight. Yeah, the 257, that was probably the tightest one in there. So that may give you a pretty good run out. Some of the others not. Maybe a little off. I'd still recommend it. I will be finishing up the runouts on them, and I'll get the spreadsheet filled on the computer and get it printed out, and then I will have a video or picture in the video of the inspection report. So once that comes up, then that'll be the end of the video, I guess. So anyway, yes, it's worth the $50-$60 just in the machining quality. It's close enough. It's a 60 more. It's probably more than a $60 worth of quality machining. It's just, you know, it's made in China. I know it is. I didn't read where it was from, but let's see, where does it say on here? Made in China. So, you know, when you get employees that only make $1 an hour, you can sell them for this. So it's worth it. I think it was going to be worth it. We'll do some testing, seating some bullets, and see how it works. If I can't get it to work with this 303 cast bullet, I may make my own stem, and we'll give that a try. So anyway, we say, well, I'll post up the picture of the inspection report and let y'all think of what y'all want to think about it, because it's worth the $60 to me. All right, thanks for watching.